Yes.
How does like we studied yesterday fit with our
Your life?
with our geometric and geometric theory?
Arithmetic and geometric?
Yeah, because like
Well, what we did yesterday was a general sequence, and arithmetic and geometric is a very particular type of sequence we'll look at. But, for example, since you're asking, your geometric sequence could be written like this, where the next term is the previous term multiplied by a number, and your arithmetic sequence could be written like this.
yeah, but what we had yesterday is confusing me.
Is
For
it?
these two.
Ah, but we haven't done it yet, so don't think about it yet. Just think about yesterday. Well, what's confusing about yesterday? We could do some more examples from yesterday.
Convergence and divergence, periodic.
Um, how many did I give you from number 4? Did I give 3? Do you need more examples of number 4? It's okay? Down the back? Do you need more examples of some of these?
Yes,
Which one?
one of three is the same.
One of which?
Yeah.
No, which one? With number 1, 2, 3 or 4? What do you need to see?
One.
Yeah? And this goes for anybody else too. Like, the next lesson is quite easy, so I have a little bit of time if you want another example of something from question 1, 2, 3 or 4 from yesterday. Yes.
Number 5, do we have to do all of it?
No, number 5, I want you, the 3 that you did in number 4.
Okay, got
Yeah.
it.
Do,
Very easy.
do we need to see something here?
Number 5.
Yeah, so you are having trouble deciding if it's convergent, divergent or periodic, is it?
Yes.
Yes, and it's not always clear. So, let's do some examples then. Okay, can we look up? Yeah, I'll do the first few. So for A, for example, you have, hey now listen, I tell you to start at -2. What's the next term? Here. -2 also. Because the next term is equal to the last term. So in this sequence, it's not too interesting. They're all the same. So you might describe this as constant. Or if you want, you can say it's periodic. Because it is repeating, but it's repeating every one time. Which is, unusual. So that one's not so interesting. The next one is more interesting. Question?
Yeah.
This is okay?
Yeah.
Yeah. So let's have a look at the next one. It's more interesting. So for B, so what you have is the next term is equal to -5 -7 over the last term. And I tell you to start at -4. So that means the next term is -5 -7 over -4.
At -3.
You have -3, is it?
No.
-13 over 4?
Yeah.
Yeah. So that's the next term. Then after that, it's -5 -7 over the last term, which was -13 over 4. So when you type this into the calculator, you get -37 over 13. Now, if you do this a few times, if you jump up to x6, so that's x3, 4, 5, and 6. After a few terms, this will be x6, which is minus 1.882. Now, it's not completely clear. This could still be divergent, but it's probably convergent because it's not growing too quickly. So if I jump to 7, 8, 9, the 10th term is minus 4.647. So even now I'm thinking maybe it's convergent, but it's possible that it's still going down to minus infinity. So I might have to jump a bit more. But as I start to increase, it's looking like the x is kind of stuck. It's having trouble getting much more negative. It's now if I just keep pressing equals here.
So we need to pick numbers, or like if we see the formula, we know that it's divergent or convergent.
No, you just have to look at the numbers you're getting. Do you know what I mean? Like there's no formula. It's almost a bit like a guess. You know. So what do we think about this one? I'm generating terms and it's having trouble settling down on something. But I've never gotten bigger than 10. All my answers are always oh no, I got a 41. I've never gotten bigger than 50. So actually, I wonder if my answer is right or wrong here. I said for B, it is divergent. Now, here's a question. What do you think you would call the sequence that doesn't move to a limit, that it keeps changing, but it doesn't go to infinity? So for example, imagine you have a sequence like this. It goes something like, I don't know, it goes 1, 1.1, 2.1, and then it goes back, goes 1.1, 2.1, then it goes minus 0.6. That it doesn't get too big or too small, but it keeps changing. It never reaches a value. Would you call this convergent or divergent? What do you think? So remember, convergent we think of when it goes to a number. Divergent we think of as it goes to infinity or minus infinity. But what about a function that doesn't move towards a number but doesn't move towards infinity? What do you think that's more convergent or divergent? What do you think? Yeah, convergent, divergent, what do you think? Really it's divergent. Okay, so if you want to think about it like this, convergent, the C means it should be moving to some constant value. Everything else we call it divergent, which usually means it moves to infinity plus or minus, but sometimes it just means it almost looks random. It just goes big, small, very big, very small, stays the same, big again, small again. This is not convergent. So we say it's divergent. Okay? So really what you should think is it convergent or if it's not convergent? And not convergent we call divergent. So B here, yeah, divergent is the right answer. Yeah. For the fun of it, let's see what this graph looks like. Because I'm picturing it'll be one strange looking graph. While that's loading, let's have a quick look at C. UN equals minus 2, UN minus 1. U1 equals minus 7. Okay, so what's U2 here? Yes. Oh, I got one more. 14. U3 minus 28. U4 56. So is this convergent? Definitely not. It's getting big and then small and then big and then small. So what is it?
Convergent.
Not convergent. Divergent. Convergent means it's moving to one value. Is this moving to one value? No. It's getting small, big, small, big. The values are going like this. Yeah? The next value won't be U5. It'll be minus 112. And U6 will be 224. Let's have a look at that previous one. What did I tell you to start with? I said start with minus 4, wasn't it? So
What's the difference between the two?
convergent and divergent.
Yeah.
Convergent means the sequence starts to move towards one value, and the values between the neighbours are nearly the same. So for example, you could have like 1.9, next is 1.99, next is 1.999. The differences are quite small, aren't they?
Mhm.
This sequence is slowly moving towards 2. Go
What
on.
if you like get like
Yep.
more or less with the first that came before?
So like it's like 1.9, 2.1,
Yeah, and
1.99.
1.8.
Yeah. And next, give me an example. Yeah, actually give me some numbers. So what's your first one?
1.9.
1.9, yeah.
2.1.
2.1, yeah.
1.8.
1.8, okay.
And 2.
And give me some more.
2.5.
Okay, 2.5. Next.
2.8.
2.8. Next.
3.
3. Next.
3.1.
Okay. Give me two more. Two.
2.9.
2.9 again, okay. And next.
3.4.
What do you think? Convergent or divergent?
Divergent.
I don't think you can say it's divergent. It wouldn't be clear. It could still be convergent because maybe much later it will go 3.45, 3.45, 3.45. Like maybe it's trying to reach this. I can't, from your example here, I can't tell. If I was to make a guess, I would say I think it might be convergent. But without calculating more terms, I wouldn't know. I couldn't tell from this.
But like sometimes it's decrease and sometimes
Yeah, sometimes increase, sometimes decrease. It could still be convergent. It could still be divergent. It's very difficult to know sometimes. Yes. I do not have any secret way to decide. Well, no, that's not true. There is a way that you can use in a later class to help you decide, like a formula. Yeah. Right now we just have to guess. This is, huh? Yeah, but in the exam it will always be very clear. Let me give you an example. So in the exam you will get something like this. Look, 1, 10, 40, 5,000, a million. Which is this? This is definitely divergent. And something like this. Now guys, please don't talk when I'm talking, please. 1.5, 1.8, 1.9, 1.99, 1.999. This one is convergent to 2. It could also be like this. The plus minus thing is okay. So you could have something like 1.9, 2.1, 1.95, 2.05, 1.995, 2.0001. Convergent or divergent?
convergent.
Convergent to 2 as well. So it can move like this to the 2, or in the first one, it's moving from underneath. The second one here, it's kind of settling down to 2 like this. Yeah?
So divergence can be like very frequent between terms, like moving up and
Divergent can be crazy. Divergent could be like this as well. Divergent could be 1, 6, minus 10, 1,000, minus 40,123, and a 4, 2. This is divergent. It's not going anywhere. Yeah. Okay. Are we a little bit clearer on convergent and divergent?
yeah.
I hope so. Right. Now I want to draw this weird one here. Minus 5 minus 7 over the last one. Alright, so let me go as far as 200. Let's see what chart we get. Yeah, it's weird. So it's going up and down, and then you can see here at about 170, it hits 500, and then it jumps back down. Yeah, so let me only go up to 150. Let me delete some of these. Okay, so let me delete all the way up to 150. No, delete. Oh, okay, so right. So let's have a look at our graph. So this is up to 115. You see what's happening? It's changing a little bit, and then all of a sudden minus 20 changes a little bit, and then 10 changes a little bit, and then 20 changes a little bit, and then all of a sudden it goes to minus 60. Then it changes. So I'm thinking if I continue this graph out, you're going to see this appearing again. That it'll change a little bit, and then all of a sudden it will hit a big number and then go back, then hit a negative number and go back. But each time it hits a big or a small number, it's bigger than the last one. So divergent. Divergent.
Because it's like change little bit and go back to the number.
Yeah, but the thing is, it doesn't stay at the number. So you think it's like if you were here, you're thinking, this is convergent, until bam, now it's not convergent. Or if you were standing here, you might still think, okay, we're convergent, bam. No.
But
So
like
it's trying to trick you. Yeah. You think it's convergent until it hits a
like
spike.
likely to be
Yeah, but this is the thing. If you were only looking at this piece and you said it's convergent, you'll be right to think it was convergent. But then if you take one extra piece, you'll see, oh, maybe it's not convergent after all. Yeah. So this one, I don't know. It's a troll sequence, I guess. You think it's one thing and then all of a sudden it tricks you. So it's divergent. Yeah, you all know what a troll is, don't you? Yeah, good. All right. Okay. Don't worry. In the exam, it's not going to be like this. It's going to be pretty clear if it's convergent, divergent, or periodic. Okay. So last time we were talking about sequence. This time we're going to talk about series. Who am I missing now? I'm missing 4 people only, isn't it?
Yeah.
Remo,
Pony,
Pony, Nina, and Albert. Okay. We think they're all at immigration. Yeah. Okay. Right. Series. So all a series is adding the terms of a sequence. So for example, here is a sequence. 2, 4, 8, 16, and then this is a series. 2 plus 4 plus 8 plus 16. So with a series, you do get a single number answer at the end. With this, it's a sequence, so you use all the numbers. Okay. Don't mix the vocabulary up, sequence and series. Okay. Can I go down?
No.
Not yet. Yes? No. Let's see. So we have sequence, and then we have a series. But does anyone know the name you could give to both? So there's almost like a family name for both. So you have a sequence and a series, but there's some word that describes both of them. Because if you look, they both have the same numbers. The only difference is the plus.
Progression.
Oh, very good. Progression is what you would call both of them. So they're both progressions. A sequence is a progression separated with a comma. A series is a progression separated or joined with a plus. Yeah? So when you were talking about arithmetic progression,
Yeah.
arithmetic progression, we will study both an arithmetic sequence and an arithmetic series. Okay, can I scroll down? Yeah. So please take care with these 3 words. Right, so imagine I have this formula un equals 2n. The sequence, u1, what's the first term? 2. Second term is 4. And third term is 6. If I want you to add the first terms to the first 3, yes? Is it? 2 times 3 is 6. What? Say what? I'll just pause for you to figure it out. Ah, ah. He's using multiply. Yes. This is okay? Yes. So if I want you to add the first 3 terms together, I would write it like this. But of course that's very inconvenient if you have many, many terms. So we use this special symbol here, which means summation, add them all up. So if I write something like this, it means I want you to take the sequence un, to start at 1, to finish at 3, and to add each term together. So this is the exact same thing as that.
Why do I have equals what?
Here,
Yeah.
why not? Tell me. Because it is possible, it's fine to write something like this. And that would mean you start at the second term.
It should be not like bigger than 5.
Yeah, there's a big problem if it's bigger than 5, you're right. So as long as it's smaller than 5, you're good. So this would be u2 plus u3 plus u4 plus u5. Yeah?
Yeah.
Okay. So often we write the formula beside it. Can I scroll down? Yep, okay. So for example, if I write something like this, n equals 0 to 4 n squared, that means you start at 0, 0 squared, plus 1 squared, plus 2 squared, plus 3 squared, plus 4 squared, which would be 1 plus 4 plus 9 plus 16, which is, well, 16 and 4 is 30, isn't it? Okay. Um, I want everybody to do this one for me. N equals 1 to, let's say, 5, 1 over n. I want everybody to calculate this. Got an answer? What did we get?
137.
What did we get?
137.
Are you sure?
Five.
Are you sure?
Five. What? 37 over 6.
137.
Oh, sorry, I thought you said point, not over. So
Oh.
sorry. Yeah, as a decimal, what is it?
Oh. 2.28.
Yeah, 2.28. So this is 1 plus, well, 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5. That's 2.283 about. Yeah? Now, you're, let me show you something here. Okay. Right. Not this one. Not this one. This one. I don't think it'll be. Okay. Watch. Okay, hang on. I can't see. I need this. Alright, hang on, hang on. Yeah, okay. You see, on my calculator, I can. Steady. What? Yeah. Yes, how did I do that? So this calculator has this function on it. You can calculate it.
Where is it?
Good question there. So I can, not on this calculator. Maybe on this one. Weird. Not on this one. Bad luck. Not on that one. Definitely not on that one. Not on that one. You have it. He has it on his one.
Oh, okay, good, good.
No. Are you the only one who bought the calculator I recommended?
No, I
You already had it.
yeah.
Yeah, you might have to order it online or in Argos or something. Do you have a calculator? Yeah. Which one have you got? Similar to that one. Okay. Anyways, I'm just saying that. I mean, you don't need it, but it is a way to check the answer. You're the only one with this calculator. Okay. Nina and Tony have Okay. Right, well then I won't show you how to do that because nobody has it on their calculator. Right, one person with the calculator and everybody else too, calculate this one for me. Ah yeah, now you wish you had the calculator.
Five,
Yeah.
five,
Five?
zero.
Uh,
Five.
that's not what I got.
I will quote nine.
Yeah, 9, 8 or something, yeah. Oh yeah, if you round it, yeah.
Yeah.
9, 8. So if you go to 2 decimal places, 5, 5, yeah. Did you get the same thing on your calculator?
I counted.
You counted good. Right, do this on your calculator. Just for you.
Two, one, three,
Tell me what you get.
six, five, five.
Mm. Got an answer yet? No. So your calculator is going through all of them from 1 to 1,000. It'll take some more time. And then if I asked your calculator to do this, I might break it. Yeah. By the way, if you're wondering, this is the answer here for this one. If you're wondering. Got an answer yet? Tell me at the end. So the point I'm making is here, you don't need the calculator for this one because in the exam, the maximum I think they would give you is maybe 8 altogether. Okay, so you don't need the calculator for this. Oh, and by the way, this here anybody know this one? Is equal to this. Yeah, pi squared. Yeah.
Zero answer.
Yeah. Now, uh, what's interesting here is you can use the same language of convergent and divergent. So, for example, look at this series. If I add this together, n is from 0 to infinity. This would be 0 plus 1 plus 2 plus 3, etc. Now, what's the total here? Is it a fixed number or is it infinitely big?
Infinite.
It's infinite. So we can call this series divergent. But the example I showed you a moment ago of this one, where it's 1 plus 1 over 4 plus 1 over 9, etc. This total is not infinity. In fact, it's this number. So we would call this one here convergent. Let me give you one like this. Suppose you have a series 1 plus a half plus a quarter plus an eighth plus a 16th. Does anyone know what this totals? No?
Less than one.
More than 1, because I started at 1 here.
It doesn't reach two.
Doesn't reach 2, but if you did it forever, the total would be 2. And the only reason I ask you this one is because this is a middle school problem. Maybe if I draw the problem, you might recognize it. So you have the wall here, and you have your grass here, and this is a distance here of 2 meters, and you have your frog here. There he is, look how happy he is. Or spider or whatever. Yeah, what is that? So this one here, he hops half the distance from here to the wall. So how much does he hop on the first one? 1 meter. And then he hops half again. So how much does he hop here? Well, in total 1.5, but this one is 1 and this one here is a half. And then he hops half again, a quarter, and then he hops half again. Now, does he ever reach the wall?
Yeah.
Well, in real life, yes, but the idea is he's only hopping half each time. So he doesn't quite reach the wall, because whenever he's a distance from the wall, he only moves half that distance. But you can see that in total, how much could he move? At most is 2. And you can see that the 2 meters is the 1 plus the half plus the quarter plus the eighth, etc. Did you not do this in middle school?
No.
This is an Irish thing then, is it? Yeah? Okay.
The crop of the equation one.
Yeah, but no, the example with the frog.
No.
No? Alright, okay. Surprising. So anyway, you've seen this before? No? Okay, alright. So anyways, my point is we can still use the language of convergent and divergent to describe this. Okay? So this one here is convergent or divergent? Convergent. Here it's convergent to 2, and here it's convergent to the wall. We can still use the language like this. We don't have to use a number. Okay? So if something was moving, if I was moving towards here, but I never quite reach it, I just get closer and closer. It's wrong for me to say I move to here, because I never reach it. The English is we say we converge to it. We never quite reach it, we just move to it, getting closer and closer. Yeah, convergent and divergent. Okay, let me give you some to try. Down the side. S to Z. You see that? Yeah. Down the side. S to Z. I can close my frog